Good morning. Welcome back to the class. So today we'll go for conversion between different system. Okay. Previously we learned about converting decimal number to binary number to decimal number, binary to octal, octal to binary, hexa to binary, and binary to hexa. Today we'll go for any other system like octal to decimal or octal to hexadecimal or decimal to hexadecimal or hexadecimal to octal, like that. If any conversation is there, converting between any system to another system. So first we'll go for converting a base 8, that is suppose a base 10 number 126 base 10, and we want to convert it to base 8. Now the decimal number is converting to an octal number. So from decimal number to any number, when we are converting a decimal number to any number, either a binary number or an octal number or a hexadecimal number, divide the number by the base number. That means in case of binary number, from decimal to binary, what we did, we divide the decimal number by 2, and each time we note down the remainder. Okay. So in the same way, if you are dividing any number by 8, the remainder is always between 0 to 7. It never being 8, and that is a octal number. If you are dividing any number by 8, then the remainder must be between 0 to 7, and the 0 to 7 itself known as a octal digit. So here I am going for this example. Suppose the base 10 number is 126, and we are dividing this into divided by 8. So 126 dividing by 8. 8 1 that 8, 2 4, then 46, 8 5 that 40, the remainder is 6. Again go for 8, 8 1 that 8, the remainder is 7. Now the number is 176 base 8 is the equivalent octal number. Okay. Now in the reverse way, suppose you are converting an octal number to a decimal number. If you are converting an octal number to a decimal number, the same process we have to use whatever we used in binary to decimal. That means we have to multiply the number into base into 8 to the power n, where n is the position of the digit, whatever we did in the binary system. Now suppose the same example I am taking 176, I want to convert it into base 10. Then what happened? From the right hand side we have to write down 6 into 8 to the power 0 plus 7 into 8 to the power 1 plus 1 into 8 to the power 2. So 8 to the power 0 is equal to anything to the power 0 is equal to 1. 1 into 6 is equal to 6. 8 to the power 1 is equal to 8. 8 into 7 is equal to 56. And 8 to the power 2 is equal to 64. 64 into 8 is equal to 64 into 1 is equal to 64. Now this is 6, 12, 12 plus 4, 6, 1, 5, 6, 11 plus 1, 12. 126 is the result with base 10. So here 126, we are converting 126 by dividing method. We are dividing by 8, so we will get the number 176 base 8. And we are converting 176 by the multiplication method. Then what happened? We are getting the same number 126. This is how we can convert any number to any decimal number to a specific number. any decimal number, if you are converting to a number system having base n, then we have to divide the number by n until you will get any number that is less than that n or 1. So now one more method is there for converting an octal number to decimal number and decimal number to octal number using the binary number. You know how to convert a decimal number to binary and binary to octal. Okay, so we have to use the binary number system as a mediator for converting decimal to binary. The same example I am taking, 126 base 10 is the number. I want to convert this number into octal number using decimal number system. Now for that, first we have to convert this number to decimal number. For that we have to divide this number by 2, that is 6, 63, the remainder is 0, again divided by 2, that is 31, the remainder is 1, again divided by 2, that is 15, the remainder is 1, again divided by 2, that is 7, the remainder is 1, again divided by 2, that is 3, the remainder is 1, divided by 2, 1, the remainder is 1. So now the number is from 0 to of we are taking, then the number is 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 3, 4, 5, 6 ones, 1, 2, 3, 4, 5, 6, 6, 1, then 0 with base 2 is the number. Now we can convert this binary number to octal number. For that, from right to left we have to take, that is 0 into 2 to the power 0 plus 1 into 2 to the power 1 plus 1 into 2 to the power 2 plus 1 into 2 to the power 3 plus 1 into 2 to the power 4 plus 1 into 2 to the power 5 plus 1 into 2 to the power 6. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Now 2 to the power 0 into something is equal to 0, 2 to the power 1 is equal to 1, 1 into 1 is equal to 2 to the power 1 is equal to 2, 2 into 1 is equal to 2. Now 2 to the power 2 is equal to 4, 4 into 1, 4, 2 to the power 8, 2 to the power 3 is equal to 8, 2 to the power 4 is equal to 16, 2 to the power 5 is equal to 32, 2 to the power 6 is equal to 64. The number is 64 plus 32, that is 66, 96, 96 plus 16, 102, 112 plus 8, 120, then this 626 is the number with base 10. The same thing we are getting if we are converting the number from binary to decimal to binary and decimal, again binary to decimal. Now what we have to do, we have to convert this number into octal number. So for converting this number into octal number, we have to make group of 3 digits from the right hand side. So this is one group, this is another group. Now 2 digits are missing from the group, so I am putting 2 zeros over, putting 0 at the left hand side doesn't change the value, so the number is 0, 0, 1, 1, 1, 1 and 1, 1, 0. 0, 0, 1, if you got the equivalent binary code, 0, 0, 1 is 1, 1, 1, 1 is 7 and 1, 1, 0 is 6. That is 176 base 8 is the equivalent binary, is the equivalent octal number. So for converting a decimal number to octal number, you have to process either by dividing the number with 8 and taking the remainder. Another is by first converting the decimal number to binary number and again from binary number to octal number. In the same way, if you want to convert a hexadecimal number, that is base 16 to base 10, base 16 to base 10 or base 10 to base 16, you can use the binary system, that is base 2 as the intermediator between these two systems. That means whatever be the number system having your this base 16 system, you have to convert that system into binary system. Again, from that binary we can convert it into the decimal system. For example, suppose we have a number now A3 base 16. Now we can convert this base 16 number or hexadecimal number to binary number. The code of A is 1010. I told you. How can you remember these codes, or how can you obtain that code? If you are obtaining this code, so the code of A is 1010 and 3 is 0011. We get the number in now from hexadecimal to binary number system. We are getting this number system binary. From binary you can convert it to octal, or binary you can convert it to decimal. Suppose I am converting binary to octal, then we have to create the group of 3. This is first group, this is second group, one number is missing, that is the third group. Now 010 is the code of 2, 100 is the code of 4, 011 is the code of 3. The number is now 1243 base 8. And if you want to convert this number into decimal number, then what happens? The same process you have to use from the right to left, that is 1 into 2 to the power 0 plus 1 into 2 to the power 1 plus 0 into 2 to the power 2 plus 0 into 2 to the power 3 plus 0 into 2 to the power 4 plus 1 into 2 to the power 5 plus 0 into 2 to the power 6 plus 1 into 2 to the power 7. Now this is 1, 2, 0, 0, 0, 32, 64, 128. So 128 plus that is 1, 2, 3, 5, 9, 17. 17, 7, 1. Now 3, 9, 11 plus 1, 12, 2. Then 1 plus 1, 2. 227 is the equivalent decimal number. This is the way how you can convert any number system from any number system, or from binary to, using the binary you can convert any number system to another number system. That's much for today. Thank you. I will give you some examples so that you will solve yourself. Thank you.